Hello there, mathletes. Welcome back to Math Jamboree. In this video, we have another AP Precalculus type of a question from the topic of polynomial functions and complex zeros. Let's solve it together. The polynomial function p of x is equals to x minus 3 times x squared plus 2x plus 5. Which of the following describes the zeros of p? So to solve this kind of questions, we're going to look for the roots of the polynomial. To find the roots of the polynomial, we're going to use the factors, and we'll make factors equal 0, and we will solve for x. So there are two factors given for this polynomial. Let's write each of them as equal 0 and solve for x. So we're just going to add 3 to both sides. So x is 3 on this one. On the other one, is there any such factor that we can use here? X, and when you multiply 5, the factors of the 5s, 5 and 1, but when you add them, you don't get 2. So we're going to use ax squared plus bx plus c equals 0. We're going to use the quadratic formula. So the a is the number in front of the x squared. So a is 1 for this factor. And the value of b is 2. And the value of c is 5. So let's write our quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac divided by 2a. So let's substitute the values in. X equals negative 2 plus or minus square root of b squared 2 squared minus 4 times 1 times 5 over 2 times 1. So if you will simplify this, x equals negative 2 plus or minus, inside of the square root we have 2 squared is 4, 4 minus 4 times 1 times 5, which is 20. So 4 minus 20 gives us negative 16 over 2. So we can write x1 as negative 2 plus square root of negative 16 is a complex number. So it's it's technically 4i over 2. And x2 is negative 2 minus 4i over 2. As you can see, we can simplify these as well. And x1 is negative 1 plus 2i. And x2 is negative 1 minus 2i. So we have one distinct real zero, which is 3. So the factors are 3 is real 0. And the other one is negative 1 minus 2i and negative 1 plus 2i. These are non-real zeros. So there are 2 non-real zeros as a factor. So because of that, the correct answer is choice D for this question, because it says P has exactly one distinct real zero, which is 3, and 2 non-real zeros, which are negative 1 and 2i and negative 1 plus 2i. So this is how we solve this question. I hope you found this video helpful. If you did, please give it a thumbs up. If you have questions or comments, you can always leave it below there. Thank you, and see you next time. Bye-bye.